Hello everyone, hope everyone is fine and doing good. So what is update? Well, update is this is gonna be the third video on kinematics video lecture series #03. In this video we are going to discuss speed and velocity in detail. So let's get started. Let's take a very simple example. Suppose an object moves from point A to B and the distance between the points A and B is 500 meter. And let's assume the time taken by the object to complete this 500 meter distance, it is 50 seconds. Now what I want to calculate, I'm interested in calculating the distance traveled by the object per second. So for this I will use the concept of direct proportion, and it is intuitive because if I increase the time of traveling, then the object might be traveling the distance greater than 500 meter. So for this I can say in 50 second distance traveled is 500 meter. So in 1 second distance traveled is 500 meter upon 50 second, right? And it will give me the value 10 meter per second. So this is what distance traveled per second by the object, right? So what is this? This is nothing but the average speed, right? So let's write down here, this is average speed, and the formula is what? Total distance upon total time. How it is? See here what I have done, I have just divided the total distance by the total time so that I can write down this formula here. Okay. Similarly, if I replace the total distance by total displacement, then it will give me average velocity. So let's write down it here. Okay. Now the question is, why I'm calling this as average speed? Well, the reason is because we don't have any information about the object, how the object is going from A to B. It is possible that object might be traveling with speed greater than or lower than this much value, and it is also possible that the particle or the object might have taken hold at some places. So to include all of these, what we can say that this is nothing but the average speed. Now let's assume the object moves with constant speed from A to B, and if it is then we can say the speed of the object at every single instant of time, that is what we called it as instantaneous speed, right? So instantaneous speed is the speed at a single instant of time. So in this case, that instantaneous speed is going to be equal to average speed of the object. So we can write down it here. If object moves with constant speed, then instantaneous speed is equal to average speed, right? Very important thing here. So let's make it star mark. Similarly, if we consider the object moves with different speeds at different instant of time, then of course it is not going to be true. For this case, what we can do, if object moves with different speed, then instantaneous speed is not equal to average speed, right? So this is what a very simple understanding of this concept. Now, to understand it better, let's make analogy. Let's assume this is a class of 50 students, okay, and now I have the data of the weight of each and every student from this class. So let's write down this as 50, 45, 40, 65, 70 and up to 50 term. Okay, now what I want to do, I just want to find out the average of all of these values. So for this, what I will do, I will do the sum of all of these values divided by total value, total number of value. Okay, and let's assume this value comes out to be, suppose 55, right? So what does it mean? 55 is the average, right? So here if you notice 55 is the average. What does it mean? This 55 kg represents the whole class, right? And yeah, that is true, the weight of each and every student is not going to be 55 kg, right? But that single quantity represents the entire class. In the same way, this 10 meter per second represents the entire journey. Okay, however, it is not necessary that the object might be moving with that velocity. Okay, so this is what the average value, we can say average speed. Now let's take a look on this expression, average velocity is equal to total displacement upon total time. Now here you can notice displacement is a vector quantity, so the average velocity is. Now the question is what is the direction of average velocity? So from this equation it is clear that the average velocity is always in the direction of displacement, right? So let's write down it here. Average velocity is always in the direction of displacement. Okay, again it is a very important statement, so let's make it star mark and we will see later after a couple of minutes how it is. Okay, so now let's discuss some questions based on these formulas. But before that, I just want to bifurcate the types of question based on speed. So let's see what are these. So let's take the first case of constant speed, and in constant speed we have three sub cases. So let's discuss one by one. So here the first case is constant speed, and here we have three sub case. The first one is constant speed in one dimension. Second is constant speed with continuous change in direction. And the third one is constant speed for some time interval. Okay, and now let's see one by one what are these. So I'm taking the first case here, which is constant speed in one dimension. So let's take a question from this segment. So for this, what I'm going to do, I'm just taking a Cartesian coordinate system. Here I take two different points. Suppose this is point A and this is point B, right? What are these? This is the initial position and this is the final position. And similarly, I can say the object moves from A to B, and the time taken by the object, let's suppose it is 10 seconds. And to represent the location of these 2 points, let's take Cartesian coordinate, or the position coordinate of this point. Let's assume it is 2, 4 and it is 4, 8. Okay, so what are these? These are the Cartesian coordinate of initial and final positions, right? Now what I want to determine, what is velocity of the object. Okay, what is velocity of the object? So for this, what I will do, I will join this origin point to the locations of A and B, and let's call it as vector r1 and this is vector r2. What are these r1 and r2? These are the position vectors of point A and B respectively. Okay, so these position vectors gives us the information about the direction and magnitude of these points distances, right? Okay, so for this, what I will do, the first task is to determine the form of this r1. Basically what I want to do, I just want to represent the location of these points by vector notation, right? So let's do it now. Here this is what the position vector corresponding to point A. So for this, what I will do, I will write down the position coordinate along x-axis, this is 2, plus position coordinate along y-axis, which is 4 over here, right? Now what I do here, I need to include something which can tell me which coordinate is along which axis. So for this, I am using here, this is I cap and this is j cap. What are these? These are called unit vectors. So this I hat is unit vector along x-axis and this j is unit vector along y-axis. Okay, now this is what this is the position vector corresponding to the initial position of the object, right? Now the next task is to calculate the magnitude of this, right? Magnitude means how much large is this distance. So for this, what I will do, I will put r1 within this mod sign and take the square root of the sum of squares of the position coordinates, right? If I do this, then I will obtain, it is 4, it is 16, so I will be getting under root 20. Okay, under root 20. Now the next task is to determine the direction. So for direction, I would be needed the information of this angle theta 1. Let's call it as theta 1, which is the angle made by this position vector r1 with the x-axis. Okay, so for this let's isolate this triangle over here. What I have done, I have just isolate this triangle, and this length is how much? This is 2 meter, and this height is gonna be the 4 meter, right? So I can say tan theta is equal to 4 upon 2, right? Basically what I have done, I have just applied the trigonometric ratios, and you are already familiar with the trigonometric ratio. In class 10th you have already read it. Okay, so this is what this is the value of theta 1. So let's close inside a bracket. Now this single vector notation gives a lot of information, right? The first one is the magnitude, this length basically, and it has given also the direction of this position vector, right? Now similarly for this position vector r2, I can do it very quickly. So I can write down this r2 vector as, this is 4i plus 4j. This is the vector, position vector corresponding to final position B. And what is the magnitude of this? Magnitude of this is 4 square plus 8 square, that will give me 16 plus 64, and it will give me how much it is? It is under root 80, right? Meter. Similarly, I can find out the location of this point B. So for this I need to calculate this angle theta 2. Okay, so let's do it very quickly. Tan theta 2 is equal to 8 by 4, and it comes out to be 2, right? So this is what this is the angle theta 2, which represents the location or the direction of this final point B. Now let's calculate the value of velocity of the object. Now to calculate the velocity of the object, we need to calculate the displacement vector. Let's call it as vector D. So this vector D is written as R2 minus vector R1. What is this R2? R2 is the position vector of the final position, and R1 is the position vector corresponding to the initial position. So that's why we need this expression, the position vector of final position minus position vector of initial position. So this is the way how we can represent or write down the displacement vector. Now let's see what is this. So R2 is what, this is 4i minus 4i plus 8j minus R1. R1 is this, right? So it will give me 2i minus 4j. So from here we will be getting 2i plus 4j. This is what the displacement vector. Okay, now let's calculate the magnitude of this. So magnitude of this will be 2 square plus 4 square, that will give me under root 20. And now to determine the direction, let's take the angle theta 3, and it will be 4 divided by 2, that will give me the value 2, right? So this is what this is the direction of displacement. Now let's calculate the velocity. So average velocity can be written as displacement upon time. So let's plug in the displacement form, vector form of displacement over here. So it is 2i cap plus 4j upon, what is the time? Time is 10 seconds, right? So let's plug in over here. So we'll be getting 1 over 5 I cap plus 2 over 5 j cap. So this is what the average velocity vector. Now let's find out the magnitude of this. So magnitude of this will be 1 over 5 square plus 2 over 5 square, that is under the square root, and it will give me finally 1 over 5 1 over square root of 5, right? So this is what the magnitude. Now what is the direction of this average velocity? So for this, let's take it is tan theta 4, and if we see over here, it is what coordinate of y divided by coordinate of x-axis, right? So that's will give me the value 2. So that's the magic. So what is the magic? You can see here the direction of displacement vector and the direction of average velocity vector, that comes out to the same, right? So that is always valid. Okay, so here if you notice, if you extend it the displacement vector like this, and it makes angle theta 3, then it also represents the direction of average velocity, right? So this is the first case when the speed is constant along one dimension, right? Because the object is moving along the straight line, so this is the case of one dimension motion. Now let's take a look on the second case, speed constant but the direction is continuously changing. So now let's do the question based on the second format, that is the speed is constant but the direction is continuously changing. So for this, let's assume this is the Cartesian coordinate system, and an object starts from here. The distance from the origin, this is 10 meter, and this is along negative y-axis, right? It starts from here, and after traveling this much path length, it stops here. So this is the point on x-axis, and let's assume this is also equal to 10 meter from the origin. And it is also given that the object moves with the constant speed, and the time taken by this object is 10 seconds. Okay. Now the question is, what is the average velocity? So for this, I would be needed the information of position vector corresponding to this point A, and let's assume if this point is B, and let's call the position vector, this is R2, okay, and this is R1. So R1 can be written as, we can write down this as minus tan J, because it lies along the negative y-axis. And similarly, R2 can be written as plus tan I cap. Now, since I need to find out the average velocity, so for this, I should have the information about the displacement. So this AB is the displacement, and let's call this as the displacement vector. So the displacement vector D can be written as R2 minus R1. Okay. Now let's plug in these vector form over here. So this is tan I minus tan J. So that will give me tan I plus tan J. So this is the vector form of the displacement. Now the next task is to find out the magnitude of this, and the magnitude of this comes out to be, that is under root 200. So this is nothing but tan under root 2. And the angle, the direction of this, that is tan theta, that will give me tan upon tan, that comes out to be 1, so theta comes out to be 45 degree, right? So this is the information which we have obtained from the vector form. Now let's calculate average velocity. So here average velocity is distance, no, it is displacement upon time. So if I plug in the vector form of displacement over here, which is tan I plus tan J, and it is divided by time. What is the time over here? This is 10. So it will give me I plus j. So this is what the velocity vector. Now the next task is to find out the magnitude. So the magnitude is comes out to be under root 2, and the direction is comes out to be 1 upon 1, which is theta equal to 45 degree. Let's discuss the question based on third format, that is the constant speed for certain time interval. So let's see the question. The question is an object moves from A to B, and the total distance is given x. The total time is t. Now it is given in the question for first 1/3 of total time. Object moves with speed v1, and similarly for second 1/3 it moves with speed v2, and similarly for third 1/3 of t it moves with speed v3. Now the question is what is the average speed, or what we can say the average velocity, because this is the case of the one dimensional motion, so we can say both are equal, right? So let's see. So for this we apply the formula average speed is equal to total distance upon total time. So I will put the total time, that is equal to t, but we need to calculate the total distance. So the total distance can be written as, let's suppose it is d1 plus d2 plus d3. d1 is the distance which is travel in first 1/3, so it is equal to t upon 3 multiply with v1. Similarly d2 can be written as t over 3 multiply with v2, and d3 can be written as t upon 3 multiply with v3, right? So let's plug in over here. It will give me value v1 t upon 3 plus v2 t upon 3 plus v3 t upon 3 divided by t. So when we solve it, then we get average speed, that is v1 plus v2 plus v3 upon 3. So this is our answer of this question. Now the question is how it is the case of third format, means speed is constant for certain time interval. Basically when you notice here, it is given the object moves with the velocity, or you can say the speed v1 for first 1/3. So during that time, during the period of 1/3 of the total time, first 1/3 the speed is v1. So during that time the speed is constant, and that is same for the second 1/3 and for the third 1/3 of the total time. So in this way we can say this is the question based on the third format. Now it is the time to discuss the solution of quiz number 1, which question number 1 of quiz first is, an object starts moving from point A along this path, and it stops here. It is given that this line makes an angle 60 degree with the line joining from A to B. Okay, and the radius of this circular path is 10 meter. We need to find out what is distance and displacement of the object. So for this we need to do some construction. So let's take this point is O, and join from O to B and from O to A. So this angle is going to be 90 degree. So this angle is equal to 30 degree. Similarly this angle is also equal to 30 degree. And because OA and OB side are equal, which is equal to the radius of this circular path. So I can say this is isosceles triangle, right? So let's do it here. Let's take this point as O, this is A, this is B, and this point is M. What is this point? I have drawn perpendicular from O to this line AB. So it will divide this line AB into two segments, right? So let's take this is X, and here it is angle 30 degree, this is 5. So in triangle AOM, I apply cos 30 degree is equal to AM upon OA. So from here I can calculate AM is equal to OA times cos 30. So OA is equal to how much? It is 10. So it comes out to be 10 under root 3 upon 2. So that will give me 5 under root 3. So this is what? This is AM. AM is what? AM is this distance, right? Now AB is a twice of AM. So I can say AB is equal to 10 under root 3, right? Now let's calculate the distance. So for distance from A to B, I need to calculate the length of this arc. So this arc length is equal to, let's apply the formula theta over 360 into 2 pi r, right? So here theta is equal to how much? This angle is, this total angle is 120. So it is 120 upon 360, and here it is 2 pi multiply with 10. So it will give me finally how much? It will give me 20 upon 3 pi. Now the distance is what? Distance is equal to 2 pi r minus 20 upon 3 pi. What I have done? I have just subtracted this arc length from the total circumference. So that will give me this distance AB. Okay. So if I do it, so if I solve it, then I will be getting how much? So let's plug in this value. It is 20 pi minus 20 upon 3 pi. It comes out to be 40 upon 3 pi, right? So this is what the distance traveled by the particle. Now let's discuss the solution of question number 2. Question number 2 is, this is a triangular path, and two persons are standing here. B takes this path and reaches at the middle of this line, and A takes this path, reaches at this point. It is given that the two persons reaches simultaneously at this point, and it is also given this length is 10 meter and this angle is 60 degree. Now the question is what is the distance and displacement. So here in this case, if I want to find out the displacement, then I should join initial point to the final point. So let's take this point is P, this point is Q. So PQ is what? PQ is going to be the median of this triangle, right? And we already know that the median of a triangle divides the whole triangle into two congruent triangles. So if this angle is 60 degree, then we can say this angle is also 60 degree, and this angle is also going to be 60 degree, right? So it is going to be a equilateral triangle. And now this PQ is what? The median, right? Median of this triangle. And for equilateral triangle, we already know the median is root 3 by 2 times of side of triangle, right? Equilateral triangle. So if I plug in the value over here, root 3 upon 2, what is the side of this triangle? Because it is given 10 meter, so each side will be equal to 10 meter, and then I will be getting 503 meter is the displacement, right? Now if we talk about the distance is equal to, this is this is 10 and this is 5, so the distance is going to be 15 meter. So this is the solution of question number 2. Now it is the time to quiz number 2. So let's see what are the questions. Question number 1 is an object moves from A to B and it is given during the first one third of total distance. Object moves with speed v1, and similarly for second one third of the total distance, object moves with speed v2, and for the last one, object moves with v3. What is average speed? So this is the first question. Now in question number 2, the same object moves from A to B. Now this time it is given during first 2/3 of total time. Object moves with speed v1, and during last 1/3 of total time, object moves with speed v2. And again the question is, what is average speed? Okay, now question number 3 is, there are two person A and B. B moves along this straight line, which is 1 kilometer path, and suppose this is point first, this is point second, and the person B takes 60 seconds to complete it, right? And person A takes this path. He reaches at this point 2 after 10 seconds of A, and it is given average speed of both A and B is same, right? So we have to find out what is curved path length. Okay, so these are the questions for quiz number 2. So we have discussed so many things all together. So that's all for today. See you in the next video. So until then, keep watching and stay connected for further updates. So thank you.